Greetings everybody and welcome back to another exam video. Today we're taking a look at the 2019 Methods Exam 2. Only the multiple choice section as usual, of course, because I like to split things up. So extended response questions will be in another video posted sometime soon, hopefully. Anyways, let's just jump straight into the first question. So we have a trig question. This is like everyone's favorite trig question, and like 90% of people always get this right, I think. Anyways, we have the period and the range of this sine graph over here. So period, well, that's quite simple to calculate. You just do 2 pi divided by that coefficient in front of x, which in this case is 2/5. But notice the 2's cancel. The 5, because it's in the denominator of the denominator, it flips up to the numerator and it becomes a 5 pi. And for the range, what we do is we take the mean position, which is -2, and then we just 2 plus or minus 3. So it's going to give us, well, -2 minus 3, that's going to be minus 5. I can't do arithmetic. -5 for the lower bounds and then 1 for the upper bounds. So that's our range over there. So let's take a look at the options, and we have option B. That should be the correct one, if I know how to do arithmetic properly. Question 2. The set of values for k for which this guy has 2 real solutions is, well, that's a quadratic. And if we're concerned about the number of solutions, we're taking a look at the discriminants. I can't speak. So what's the discriminant of this guy? It's equal to b squared, which is 4 minus 4a and then c. But that's equal to 4 plus 4k. And 2 real solutions means we want this guy to be greater than 0. And solving this is fairly simple. Let's divide by 4 on both sides, giving us 1 plus k greater than 0. So k is greater than -1. So that means it is going to be option B yet again. All right. Question 3. What do we have? We have average rate of change from x equals 6 to x equals 8 is... for this one, you can just use the CAS program for average rate of change. If you want to, you can define... we don't really need to define it because we just need to use the function once. So let's go to methods, differential calculus, average rate of change, and I want a divided by x minus 4, comma x, that's the variable, going from x equals 6 to 8, and it gives us -8 over 8. Negative a over 8. So it's option E. You can also just use the average rate of change formula, just type it into the CAS. You should know what that is anyways. Alright, question 4, we have integral of this guy is equal to, so we just need to evaluate some kind of integral in our CAS, nice and simple. So we'll do shift positive for integral from 0 to pi over 6 of, well, it's a times the sine of x, and then plus, what was it, b cos of x? B times cosine of x dx. And that's equal to this guy, and well, we have, looks like we have something with a 2 on the denominator everywhere. So what I'm going to do is I'm going to factor this whole expression, and that gives us a 2 in the denominator. Now we just gotta look and match up the answers. So first of all, we have a negative distributed into this negative b, so we want a positive b in the numerator, and just a b by itself. So that kind of eliminates e, that eliminates d, that eliminates well, it could be a, b, or c in this case. We want a with a √3 minus 2 with a negative as well. But we can bring that negative there into the √3 minus 2 and switch those two numbers around. So we want the coefficient of a to be 2 minus √3. So we look, and it looks like it's going to be option C. Oops. And it can't be B because, yeah, we have a negative there, but so we distributed that negative in, so it becomes a positive. Yeah, that should be right. And it can't be A because we have a negative B, when it should be a positive B after you distribute that negative. Okay, question 5. Let's f prime be this quadratic here, such that f of 4 equals 0. We want to find the rule of f. First of all, it has to be a cubic because you anti-differentiate and this quadratic turns into a cubic, so can't be D, can't be E. And we have to decide between, well, A, B, and C. So let's just find the antiderivative of that guy first of all. That shouldn't be too tricky to do. Shift plus, and we're integrating 3x squared and a minus 2x. Okay, and we integrate with respect to x, of course, that gives us this function. Okay, so technically it's actually this function and then plus c. That's the antiderivative. And what we want to do is we want to find the value of c for which this new function here, this antiderivative, passes through the point 4, 0. So how can we do that? Well, we can just use a solve command. So what we can do is I'll type in solve this guy plus c. So this is the general antiderivative. And what I want to do is I want to, actually, let me shift my recording software up a little bit so you can actually see that line. I just realized sometimes you can't see it. So solve this guy. I want this to be equal to 0 when x equals 4. And I'll solve this with respect to c, that's the unknown variable. So it's basically plug 4 into this cubic over here, and I want to make sure it's 0, and finds the value of c which does the job, and c equals negative 48. So it's going to be option C, I believe. Actually, if you do spec, you may know a slightly more elegant way to do this, and that's doing the integral. I believe this is from the differential equations topic, but anyways, what you can do is the following. Notice that we want to pass through the points 0, 4, so y equals 0. So we're going to start at 0. So I'm going to put, in general, you want to put 0 plus over here, so whatever points you pass through. And then you're going to integrate. Now x is going to start from 4, and we're going to go up to x over here. Now instead of typing in, well, x cubed minus x squared, I'm going to type in t cubed minus t squared, just so we have a different variable, and I integrate with respect to t, and that gives us, did I do something wrong? Oh, it's 3, what am I doing? It's 3x squared. 3t squared minus 2t, and that gives us the same answer. So that's a slightly more elegant way to do it if you know how this works. That's basically fundamental theorem of calculus, if you kind of reverse it a little bit. All right. Question number 6. We have a rectangular sheet of cardboard with length 80 centimeters and width 50 centimeters. And what we want to do, so we kind of fold up, we cut these squares out and we fold up the little edges. And we want to find the volume, well, the volume of the box is maximum when x is equal to. So we want to find this x value for which this occurs. So let's define the volume function first of all. What's the volume going to be? So v of x, that's going to be equal to, the height is going to be x, the width is going to be 80. Now we chop off x on both sides, it's 80 minus 2x. Then the length is going to be, well, it's 50, and then we minus 2x. And we want to maximize this guy. So let's just define it on the CAS. Define v of x to be equal to x, 80 minus 2x, and then 50 minus 2x. Now, first of all, do you see something wrong with how I typed it in over here? And, well, the issue is, if you have a unknown constant next to a set of, well, next to a bracket, the CAS assumes that this is a function over here, not a multiplication. So if you just enter this and you try to work with this, your CAS is going to give some kind of error, because it's thinking that x of something, x is a function, but it's not, it's a variable. So make sure you put it times there. Okay, so that's v of x. And what do we want to do? We want to maximize this guy. So we're just going to simply solve when, well, actually, let's use the analyze program, just so we know what the local maximum is. So functions, I'm going to analyze v of x, comma x, and that gives us, it gives us 10. So this is the value of x which this occurs. That's the maximum volume if you need that, but we're only interested in that 10. So it's going to be option A. Okay. Question 7, the discrete random variable x has the following distribution. The mean of x is. First of all, we have a bunch of a's over here. We can actually figure out what a is because the probabilities must sum to 1. So we need a plus 3a plus 5a plus 7a equals 1. So we're going to solve a plus 3a plus 5a plus 7a equals 1 with respect to a. So a is 1/16. And all we have to do is use the formula for expected value. So we multiply x value with probability and then just sum it together. So what you can do is the following. You can do, well, we can ignore the 0 over here because 0 times a is 0. What you can do is 1 times 3a, well, could have just written 3a, and then plus 2 times 5a, and then plus 3 times 7a. And then I want to evaluate this guy such that a equals 1/16, just so I don't have to type in 1/16 everywhere. And then we get 17 and 8, and that's going to be option D. Okay, question 8. An archer can successfully hit a target with a probability of 0.9. The archer attempts to hit the target 80 times. everything's independent, so this is binomial over here, given the archer successfully hits the target at least 70 times. So first of all, let's set up our binomial random variable. We are going to let x be binomial with, well, what's that going to be? It's going to be 80 trials and then a success of 0.9. My handwriting is horribly bad. So bi and then 80, 0.9. So this is going to count the number of times that the archer hits the target. And what we want to do is find the probability hits the target exactly 74 times. So x equals 74, given that x is at least 70 times, so this is greater than or equal to 70. Okay, but you just use the conditional probability formula. First of all, we have the probability of x equals 74 and x greater than or equal to 70. But if you take the intersection of those two events, that's just simply x equals 74. Then you divide by that the events we're conditioning on. So that's x greater than or equal to 70. So let's evaluate this guy on the CAS using binom, PDF, and CDF. So let's do that. We have menu 5, and then we'll go. We're going to go for a PDF because we're at a single point at the numerator. So number of trials, that's going to be 80.9, and then we're after 74. Okay, and then we'll do menu 5B in this case for CDF. We'll do 80.9, and then we want to go from 70 up to 80. Okay, and then we'll just take this guy divided by this guy, and that gives us 0.14, and that looks like it's going to be option C. All right, question 9. The point AB is transformed by this guy over here. If the image of AB is 0, 0, then what is AB? So what we're going to do is we're going to apply this matrix transformation to AB, and we're going to set the resulting coordinate equal to 0. So what happens if you apply this transformation to the first coordinate, which is A? Well, you're just going to imagine x equals a and y equals b, and you just simply read off the first line over here. So we have 1/2 times a, and then minus 1/2, and we need that output, or that image over there, to be equal to 0. And same for the bottom line as well. We need negative 2b minus 2 equals 0, and we're just going to solve simultaneously for a and b. And to do that, very quick way to do that is just to solve. We needed 1/2 times a, and then minus 1/2 equals 0, and we also need negative 2b minus 2 equals 0, and we're going to solve this, so comma, and then just list the variables. A, b, that gives us 1, -1, which is option E. All right. Moving on, question 10. Which one of the following statements is true? So we have x plus sine of x. The graph has a horizontal asymptote. That's obviously wrong, because your graph is going to look something like this, because you're adding x to sine of x, so there's no horizontal asymptote there, so it's not A. There's infinitely many solutions to f of x equals 4, but your graph is wiggling up like this, so if there's only going to be a finite number of solutions, because you're not going to be periodic. If you're adding x to your graph, you're not periodic anymore, so it's not B. F has a period of 2π, again it's not periodic because you're adding x to it, which is not periodic. F prime of x greater than or equal to 0 could be the case, actually. Actually, it has to be, because E is wrong. F prime of x is not cosine of x. F prime of x is 1 plus the cosine of x. So we'll go with D, and just to check that it is indeed D, what's the derivative of this guy? It's 1 plus cosine, and just think about what the graph of 1 plus cosine looks like. It's something like this. It's always above the x-axis. Or, greater than or equal to 0, at least. All right, question 11. A and B, these are from a sample space such that the following hold. A and B are independent events when? So, if A and B are independent, that means the probability of B given A, the probability of B happening, just the probability of B should not depend on A at all, if A and B are actually independent. So even if we condition on A, it shouldn't change the probability of B. So we kind of want this guy to be equal to the probability of B still. And again, this is just A prime. if B and A are independent, then B doesn't care about how A behaves. So if you condition on A prime, there should still be the probability of B. But if you have these two guys, well, these two guys are obviously equal to each other, so you need M and N to be equal to each other. Right? I mean, it's just going to be A. If you're not too sure about how I got this over here for the independence, just write it out. The probability of B given A is equal to the probability of B intersect A over the probability of A. B and A are independent, which means you use the independence law there. So that's PRB, PRA over PRA. But that's PRB because the PRAs cancel out. And yeah, PRA is P, it's greater than 0, which means you can do this division over here, no problems. All right. And the same goes for this other probability over here. Just replace A's with A prime pretty much, and then you get the same thing. Okay. Question 12, we have integral from 1 to 4 of f of x, and integral from 2 to 4 of f of x, and we want to find the integral of 1 to 2. So we know these two integrals of the function f, just the function f. We know the integral of that function, which means from that we can deduce what the integral from 1 to 2 of just f would be. So what would that be? That would be the integral from 1 to 4 of f of x dx, and then minus the integral from 2 to 4 of f of x dx. Okay, but I believe we know what those are. That's going to be 4 minus, and then that's negative 2, so that's going to be exactly 6. Okay, but that's not the integral we're after. We're after the integral of f of x plus x. So what's that going to be? The integral from 1 to 2 of f of x plus x dx. Well, just split up the integral into parts that we know. So that's integral from 1 to 2 of f of x dx plus the integral from 1 to 2 of x dx. And if you want to, you can do that second integral by hand or on the CAS if you want to. This guy over here, that's exactly equal to 6. I'm lazy, so I'm just going to use the CAS for it. So shift positive 1 to 2 of x dx. That's the second integral, and I'm also going to add 6 at the very end. That gives us 15 on 2. So that's option E. Question 13. The graph of the function f passes through the points negative 2, 7. If h is some transformed function of f, then the graph of h must pass through the points. So if this point here lives on the function, and we know how we're transforming the function, then we know how this point here gets transformed as well. So what exactly are the transformations that occur over here? The transformations are, first of all, dilation by a factor of 2 from the y-axis, which means all x's get mapped to twice its value. Okay, and then we also have a plus 5 here, which means a translation up by 5 units, which means all y values get mapped to y plus 5. So if you just apply the rules over here, that means the negative 2 is going to get mapped to, that's the x coordinate, it's going to get mapped to negative 4, and 7, you're just going to add 5 to it, that's going to give you 12, so it's going to be option C. All right, question 14. The weight of packets of lollies are normally distributed. 97% of these packets of lollies have a weight of more than 190 grams, then the standard deviation of the distribution correct in one decimal place is. So we're just trying to find standard deviation. Luckily, there's a nice program that does this for you called Normal Solve. So let's go to Normal Solve here. Normal Solve. Okay, and we want to solve the mean standard deviation. Okay, the given probability is 97%, so 0.97. The mean is given as 200, and which probability setting do we want? We want greater, have a weight of more than 190. Okay, so that's option 2, and the A value is 190, and that gives us a standard deviation of 5.3. So that's option B. Now, if you don't have the programs, what you'd need to do is you need to write, well, you have the probability that your random variable x, which is your normally distributed random variable, is greater than 190. This is equal to 0.97. And, well, what you need to do is standardize from here, because there's some unknown parameters in this x here. You want to move them to the other side. So standardizing gives you z greater than 190 minus mu, which is 200, divided by sigma. And if you take a look at the program output, you actually get the z-score as well. So that means that if you just use normal inverse on this, you'll find that negative 10 over sigma is equal to, so that's negative 10 over there, that's equal to negative 1.88. And you just need to rearrange this and then you'll get your sigma. So you just need to use normal inverse for this. I believe, yeah, you just have to be careful because normal inverse on the CAS assumes the inequality is going this way. So when you plug in the area, if you do normal inverse, so menu 553, I might as well just do it. You need to put in 0.03 because the CAS assumes the area is on the left-hand side of the value you're interested in. And if you just press, yeah, that's the z-score that we got. All right, so hopefully that's clear. Question 15, we have function f of 5 equals 7, g is the inverse function of f. We want to find g prime. So this is, I've seen this question before, this is the derivative of the inverse function. So how do we do this? Well, I believe a nice way to get started with this one is just to draw a picture, just to see where everything lies, because it can get a bit confusing with all these symbols and functions everywhere. So here are the axes. What's the turning points of this guy? Well, it's going to be 2 comma something. What's f of 2? F of 2, that's 2 squared, that's 4, it's probably negative. Is it negative? Let's see. So f of x equals x squared minus 4x and then plus 2. Okay, so what's f of 2? It's negative 2, so it's going to start down over here somewhere and then just go up. So the inverse function must look something like this. It's going to start at negative 2 comma positive 2 and go up like that. And we want to find, we know f of 5 is 7. So if you go to 5 over here, maybe that's over there, I don't know. That's a 5 comma 7. This is not to scale, by the way. And we want to find g prime of 7. So g prime of 7, let's think about this. Actually, we want to put this point all the way up over here. That would be 5 comma 7. So g prime of 7, this is the point 7 comma 5 in fact. We want to find the g prime of 7, which is the gradient right at that point there. So this gradient here, again, not to scale. So how do you find that gradient? Well, you look at the gradient of the original point on the red graph, which is your original function f. So what's the gradient here? Well, I'm going to differentiate this guy. So derivative with respect to x of f of x, evaluated at x equals exactly 5. That gives me 6. So I know the gradient at this point over here, this gradient is precisely 6. But now the corresponding point on the inverse graph is not right over here. That's the gradient where I want to find g prime of 7. So the gradient over here is going to be precisely the reciprocal of 6, because remember a function and its inverse, how are they related geometrically? Well, it's a reflection in the line y equals x. But if you're reflecting the line y equals x, you're interchanging x's and y's pretty much, which means, well, for the gradients, you're interchanging rise and run, which means that your gradient is going to get reciprocated. So it's going to be 1/6. That's question 15. Question 16. Part of the graph of y equals f is shown below. The corresponding part of the graph of y equals f prime is represented by. So first thing I look at is stationary points. So stationary points here and here at precisely 5. So I only want x-intercept at 0 and 5. So A could work, B could work, D would not work because we have x-intercepts at 0, 5, and 6. E is not going to work as well, and C is not going to work because we get x-intercepts at 6 when we want x-intercepts at 5. All right. Question is it A or is it B? And to do that, just take a look at the nature of this stationary point over here. So this is a local minimum, which means on the left-hand side of that stationary point, you get a negative sign, or a negative gradient rather, and on the right-hand side, you get a positive gradient, which means on the derivative graph, on the left-hand side of the point x equals 5, your derivative graph should be below the x-axis, And B wouldn't work because on the left hand side it's above the x-axis and then it goes down to negative. A would work because it starts negative below the x-axis, then it goes positive, which reflects the gradient we have up over here. So it's going to be option A. Okay, that's 16. Moving on to 17. A box contains n marbles that are identical in every way except color, of which k marbles are colored red. So let's write this down. K are red, and the remainder of the marbles are colored green. So there's n marbles in total, so that means n minus k are green. Okay, and what do we want to do with this? 2 marbles are randomly drawn from the box. So immediately, tree diagram, because we have the first marble is not replaced into the box. So we're doing things without replacements. So let's tree diagram this. So we have branches. What do we want in particular? We want the probability that the 2 marbles are the same color. Okay, so we could go red and then green. And then on these branches, you go red, green, but you only need to write down the branches you're interested in. So when we go red, we want to go red again. There is also this other green branch, but we don't care about it, so there's no point writing it down. And then we want green down here as well. So we're just gotta, put in the probabilities. So what's the probability of picking a red marble? It's going to be k divided by, let's use blue. So it's going to be k divided by the total number, which is n. And then for green, it's going to be n minus k divided by n. Okay, so once we've chosen this red marble here, how many marbles remain? Well, because we're not putting it back, n minus 1 marbles remain. And how many red marbles remain? Well, there's going to be k minus 1 marbles remaining. So it's n minus 1, k minus 1. How about the green? We have n minus 1 marbles remaining. And then how many green marbles are remaining? It's going to be n minus k minus 1. So we just multiply the branches together, add them up, and that's our answer. So let's do this quickly on the CAS. So we have fraction, and then plus fraction, and then times another fraction. So what goes where? We have n, and then we have a n minus 1, and I believe that's the same for the other term as well. So n, and then n minus 1. And for the first term, let's take that to be the red. We're going to do k, and then times k minus 1. And then we'll do n minus k. And then n minus k minus 1. Does that simplify nicely for us? Oh dear. I realized we didn't even need to use the CAS for that one. Why on earth did I plug that into the CAS? Silly me. Just realize that if you multiply it together, we're going to get k and then k minus 1 divided by n times n minus 1. But then we're going to add something with the same denominator. So that's n times n minus 1. And, well, that's just going to be n minus k and n minus k minus 1. And that's obviously going to be option D. I don't know why I plugged it into the CAS. Maybe because I did another exam question a few hours ago that was basically the same thing as this, and I plugged it into the CAS, so I don't know. Anyways, question 18, we have the distribution of continuous random variables defined by this probability density function. So we have some things going on here. Okay, so the graph of P is shown below. So it's just some straight lines. We know that the average value of P over the interval minus a to b, which is basically where it's non-zero, is 3/4. All right. Find the probability that x is greater than 0. So, first of all, there's 2 unknowns, so we need to kind of cook up 2 equations. Well, it's pretty obvious. The first equation is going to be something to do with the average value. The second equation is going to be something to do with the fact that this is a probability density function, which means that the total area underneath is going to be exactly 1. So, why not try to find the area of this thing, first of all? In terms of a and b, you could define this piecewise and try to do integration with it. Usually that's not a great idea. Well, usually it's quite slow doing that because you have to figure out what the equations are first of all. If you have simple geometric objects like this, notice we just have it's a triangle on the left hand side and then some kind of trapezium on the right hand side. We'll just use your basic geometry. So we can just take a look at the triangle area and add it to the trapezium area. So let's do that. Let's define tri to be equal to the triangle area. What's the triangle area? It's a half times base times heights. So the base is a, the height is 2a, and we're dividing it by 2, that should just be a squared, I believe. So I'll just do a squared, I guess. And for the trapezium, so we're going to define trapezium now, equals, well, you do one of the parallel side lengths, which is 2a, or actually you take 1/2 times one of the side lengths, which is 2a, plus the other parallel side length, which is b, and then you multiply this guy by the height, or the perpendicular height, which in this case is going sideways, but that's going to be b. So that's our trapezium area. And what do we want to do with this? We want to, well, first of all, what's the average? How do you calculate average value? It's the integral, which is area, and you divide by the length of the interval. Now, the length of the interval is going to be a plus a b, because it's b on this side, and then you go a on the other side. The length of interval is a plus b. So we have a few things to solve over here. We want we know how to get the average value. It's this sum of the triangle area plus trapezium area divided by this a plus b, and that's going to be 3/4. We also want the sum of these two parts over here to be exactly 1, and we're going to solve for a and b. That's the most straightforward thing to do from here. So I'm going to solve triangle area plus trapezium area equals 1, and I'm also going to solve, I'm going to do 1 over, actually, oh dear, let's do the fraction templates first. Oh, that doesn't work. And that, oh my gosh, let's just do it like this. A plus b, or no, what am I doing? I want to do try, and then plus trap. And then I'm going to divide this, there we go, by a plus b now. So this is going to be equal to 3/4, and solve this for a and b. Oh dear. We want a and b are positive. There we go. That should simplify things. So a greater than 0, and b greater than 0. There we go. We got some nice answers. And now we just need to find the probability that x is greater than 0. But that's just exactly everything, that the area on the right hand side, which is the trapezium area. So we're just going to take the trapezium area and evaluate, or condition on a being that number and b being that number that we got there, and that gives us 7/9. So that's going to be option D. That was a bit of a fumble there with the CAS. Anyways, that's question 18, so 2 more questions to go. This question. So this is that tricky trig question. I remember doing this one actually. So how do you do this one? We have a tan of 2 theta equals d, and alpha is between 0 and pi on 2. Tan of alpha is equal to d. A nice way to think about this, because tan is representing the gradient. If you draw this out in a unit circle, this might help. So here's unit circle, and let's put a line through here. So alpha is some angle. Here's my alpha, it's between 0 and pi on 2. This is basically saying the gradient of this line is d. Now, how does that help us? Well, we want to find the solutions to tan of 2x equals d first of all. So to solve these sorts of trig equations where you have not just x on the inside but something more like 2x, you need to find the domain for 2x and pretend like you're solving it for 2x. So what I mean by that is, because we have 2x on the inside, let's adjust this domain here, which means a 0 is now less than 2x, which is less than 5 pi on 2. And we're going to pretend to solve for 2x. So tan, just pretend 2x is one variable now. You ask yourself the question, tan of what gives you d? And that's what? That angle there must be between 0 and 5 pi on 2. So basically, which angle gives a gradient of d, pretty much. That's how you interpret tan. And that's precisely over here. You loop over to here, then you loop to 2 pi. This is 2 pi, so that's 1 revolution. But you're not done yet, because you also got to go up to 5 pi on 2. 5 pi on 2 is an extra pi on 2 more than 2 pi. So you also pick up this solution yet again. Okay, so what exactly are those solutions? It's going to be 2x is equal to, our first solution is going to occur at precisely alpha, because tan of alpha is d, that's what we're solving for here. what's the next solution? It's going to be down over here, but that's precisely because tan is just a straight line through. You're just going to add pi to it. So this is alpha plus pi. I don't like it when my whiteboard does that. So alpha plus pi. And then also you loop back another time, a half revolution around, that gives you alpha plus 2 pi. Okay, so what does that mean over there? It means that x is equal to alpha on 2, comma, alpha plus pi on 2, and then comma, alpha plus 2 pi divided by 2. And what's the sum of all these solutions? Well, it's going to be, if you just look at this, there's alpha, 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 there's 3 alphas in total, 3 alpha, and then plus how many pi's? There's 3 pi's, we divide by 2. That's going to be 3 alpha plus pi on 2. And that is option E. Perfect. All right, final question. Question 20. The expression for log xy plus log yz, where all these are real numbers greater than 1 is equal to. First thing my mind jumps to, well, first of all, I've done this question already, is just to use change of base formula. So you can rewrite that guy over there to be, well, how do you change base? It's log base anything that you want, so I'll just leave an empty space there. Log base anything of y divided by log base anything of x. So that's how you do the change of base for the first part, and then you also have log base, log of z, so log base anything of z divided by log base the same anything of y. All right, now we want to match it up to one of these here, so how can I do that? I see a bunch of reciprocals everywhere, so what I'm going to do is I'm going to do a little bit of a trick here. I'm going to rewrite this as 1 divided by, and I'm going to reciprocate this guy. So this is going to be log of x over log of y, and then plus 1 over log of y over log of z. So I reciprocate everything. So hopefully you agree that everything I write here is equal. And now you look at this again, and well, you notice how we can just do the reverse change of base, because this is 1 over log base y, because y is in the denominator of x, and then plus 1 over log base z, because z is in the denominator of y. So let's match things up over here. It looks like it's d. It's not going to be b. B is basically the same terms but reciprocated. We have negatives, which we don't want, so it has to be d. All right. So that does it for that exam. I'm pretty sure it was I found it pretty tough when I did it back when I was doing exam prep a few years ago, 3 years ago actually. But I don't think it's too bad overall. Maybe that's just because I've done these questions before, I think. But yeah, it's not too bad of a set of multiple choice questions. Maybe on the more moderate, trickier ends. But yeah, overall, it's a pretty good set of questions. And yeah, we'll finish off here. So hope you guys enjoyed the video and found it useful. And I'll see everyone in the next video. Bye bye. Oops, where do I stop recording? Oh dear. No. There we go.